All right, let me go ahead and share my screen that way. So you can share look at my screen. Okay, can you see my screen now?
Yeah, we can see it.
All right, so we finished chapter 1 last time. Chapter 2 here is about descriptive statistics, okay? So as I said earlier, we are not going through the detail, but we're gonna do the review. The review will include all this detail as well, okay? So this chapter, basically you have a 5 sections: frequency distribution and a graph. And the graph is very important. So you have more graph in here. Okay, let me see. Probably someone trying to get in. Okay, so you have a graph. So we're gonna have a histogram graph. We have a pie graph, bar graph, time series graph, and also the frequency distribution, the OZI, right? And then those kind of graph we all need to know. And then from the section 2.3, you start measure the central tendency. We're gonna treat the data, so we're gonna have a mean, median, mode for all those things. And how do you find a simple bin, weighted bin, and a bin for the group of the table, right? So that's 2.3 in here. 2.4 measure the valuation. So we're gonna have a standard deviation, the sample and the population standard deviation with the formula. And as I said earlier, you can print out a formula sheet for the test, okay? And then the measure the position. So you have a file number using the Q1, Q2, Q3, the quadrant, and then with the minimum and maximum. So that is pretty much this whole chapter about, okay? And I'll also show you how to use the calculator a little bit in a question to see exactly how we're gonna use the calculator, all right?
Okay.
So this is the test 1 practice. Again, the practice is just the practice. You won't see the question exactly the same as the test in here. But the concept we use on the test, will be similar, right? We all using the same chapter 1 and 2 concepts. So this is kind of giving you a little bit more familiar with the test question, but not exactly the same, okay? Especially when you have a number calculation, it's gonna be different number for sure, all right? So any question before we begin?
Can this be found in the module section, the review?
Not in the module section, but in the link. I post this on my TCC drive. So there's a link. If you go to I just announced this evening. Okay. So test review question. If you go to the review question here, I posted this link, and this link will take you link directly to this review question, which is the one I'm using now. So
Perfect.
I post all the 4 test review in here, and some of them even with a little bit vocabulary for chapter 3 and 9. So the test 1 just include Unit 1 test. It just include chapter 1 and 2. All right. So let's go ahead. You might want to just go ahead and write down your paper pencil, trying to see at the end how many you got it right. Okay, kind of a little bit self-text that way. Okay, so the first one, identify the label of the measurement. So we have a 4 label of the measurement, right? NOIR, hair color, whatever the woman on the high school tennis team or whatever. So just the hair color. What kind of measurement is that? Okay, so question number 1, which one is the correct answer? Everyone. You can type it in the chat. Basically, you can type it in the chat here. Okay, if you want, you can type it in the chat here. go to the chat, and then you can kind of get a little bit response to see. You can just type a A, B, C, D. You don't have to type the answer. Make it faster. Okay, nominal. Okay, good. Yeah, C is nominal. Well, okay, so that is the correct one. Okay, hair color will be just the nominal one. All right, because you cannot tell which one is better. So it's just a different category, right? The age of every fourth person entering the department store. Okay, so this one to determine the data set is a population or a sample. All right, this one you do need to type in. Is a population or sample? You just type a P for population, S for sample. Okay, let's see. All right, we have a P, we have a C, we have a S. We have a sample, we have a population, we have a sample. Okay, so now we need to look at what is the population and the sample. Population, that means everyone, everywhere, right? Whatever this is referring the person. So the population here should be every person. But this one is only the age, they only count the age of everyone. Fourth person. So apparently it's, every fourth. So apparently it's not include everyone. So this is the sampling. Okay, this is a sample. What kind of sampling technique is used in here? What kind of sampling technique is using in here? This is called systematic, right? Systematic sampling technique, because it only
question.
Yeah, well, I mean, I'm just kind of expanding the question here. It didn't ask that way. This one, if you only want to answer this question with just the sample, all right. Number 3 is data qualitative or quantitative. For number 3, the color of the automobiles on the used car lot. Yeah, you probably already answered the next question. Yeah. All right. So the color is the what? Qualitative. Okay. Okay. Number 4. Now we have A, B, C, D. Let's see. Number 4, temperatures of 73 selected refrigerators. Let's see, what is the answer? I'll give you a minute, 30 seconds to think about and type the answer. Okay, so we have A, B, D, B, B. Okay, so let's take a look at it here. This is a practice, so it doesn't matter. Even you answer it wrong, just go ahead and answer, right? That means at least you are thinking that way. All right, so temperatures, we said we have a called NOIR, right? NOIR. N is for the nominal, O is for the ordinal, and then I is for the interval, R is for the ratio. So the nominal, basically, you cannot tell the difference, which one is good or which one is better, that kind of thing. That's not pretty much it's just personal preference or just category, right? Ordinal, you can actually tell the difference. You are ranking different, like A is better than B, B is better than C, those kind of things. But the detail is not obvious, okay? So that means in ordinal, addition, subtraction is very, very, very challenging. You cannot add and subtract, but you know A is better than B, that kind of thing. All right, so when you go to the interval and the ratio, details really matter. So in these two labels, you can add and subtract, and the number is still making sense, okay? So that means if you say the 73 degree, well, that means, yeah, if for the seated refrigerators, if we say the temperature, like the weather, right? If we say like the 70 seated refrigerators, okay, so temperature in 70 So we usually say how about if we have a temperature as like I say 40 degrees Fahrenheit? Okay, I think that's usually the refrigerator need to be below 40 degrees Fahrenheit, that kind of thing, right? If you set a refrigerator too low, which is like I said 30 degrees, now you know you're gonna be freezing, right? Everything gonna become frozen, that kind of thing, that way. All right. If you set a temperature too high, now all your food gonna go in bad, that kind of thing. All right. So can you tell the difference of 40 and 30 degrees? The answer will be yes, right? Yeah, you know, like these two, you know, and add and subtract 10 degrees still difference is still making sense in here. So this one will be belong to either interval or ratio. Okay, apparently it's more than the nominal and ordinal. The difference of the interval and ratio here, as we explained earlier, is this ratio has a real zero. Okay, the zero is real. Zero means nothing. It doesn't exist. That's zero. That's real zero. Interval, we call it zero, is a fake one. Okay, so if I say a 0 degree Fahrenheit, that means the temperature still exists. Okay, so 0 degree Fahrenheit, that means just means cold. Doesn't mean the temperature disappear. Okay, so the temperature here is the what? Interval. So it should be A. All right. I know that one usually pretty confused for this one right here. So it's an interval. Okay, let me give you another example. Like we have
I'm sorry. Do you mind repeat why it was option B? I didn't get it.
okay,
Hello?
so I just said it earlier. Let's say interval, the 0 is not a real 0. So the 0, it just means a position on a scale. Okay, that means in the interval label, 0 doesn't mean nothing. Doesn't mean it didn't exist. In a ratio, 0 means it didn't exist. It's real 0. Okay, 0 means nothing. It didn't exist in here. But on the temperature part, if we say temperature is 0 degree Fahrenheit, well, actually, if you convert it into different unit, 0 degree Fahrenheit is not equal to 0 Celsius, right? So if you have a 0 degree, Celsius, actually is equal to 32 degree Fahrenheit. All right, so we're gonna say this 0 is not a real 0. It's just a position on a scale, because if I convert it into different degree, different things, this is not it's not 0 anymore. Okay, so we're gonna call this 0 is not a real 0 for the interval. Same thing, if you have a 0 degree Fahrenheit, right? If you have a 0 degree Fahrenheit, you convert it into Celsius. Now this is gonna become negative something, some kind of Celsius degree, maybe negative 12 or something like that. All right, do we answer that question? All right, okay. Yes. All right, let's look at number 5. Okay, number 5. Which answer do you have? All right, give me your answer. Type your answer. And you see, now you're thinking. All right, let me see. I can do a little bit poor. All right, this might take a little bit. Okay, I'll try to do the pooling. Good. All right, so let's see, look at, this is final grade ABCD, okay? Grade ABCD, we said the NOIR earlier, right? N is nominal, O is ordinal, R is interval. Final grade ABCD, the detail, you cannot really add and subtract for this one, okay? But you do know A is better than B, B is better than C. So this is supposed to be what? Ordinal. Okay, that should be ordinal in here. All right, number 6, zip code. Which one is the answer? This should be a little bit easier. The zip code. Zip code, we have a D zip code. No, I don't know which one you answer that way. But zip code is, even if you have a number, but zip code for the Chicago, zip code is just the what? It's just the nickname for the location, okay? So you cannot really add and subtract the zip code. It doesn't make sense, okay? So that should be the ordinal in here. Okay, number 7, a poll is conducted in which professional musicians are asked their age. So is this an observation or experiment? A or B? Number 7. A, okay, a lot of A's. All right, so that is correct. Okay, because this is conduct which they only ask their age, right? So a poll is conduct in which professional musician ask their age. They don't do anything different. They just just watch, right? So that's A, observation. Okay, good. All right, number 8. Every 5th person boarding an airplane is searched thoroughly. All right, you got stuck on the security. All right, every 5th person is searched. All right, which method? So apparently this is a sampling, right? Sampling technique, because they don't search everyone. They only search every 5th person. So which one is the correct answer? Okay, all right, we got a lot of C. Systematic, that's exactly right. Okay, so this is every case person, every 10th, or every 5th, that is systematic. Okay, that's good. All right, number 9, a research randomly select and interview 50 male and 50 female teachers. Which one is that? Okay, looks like we got a lot of B. Okay, all right. I guess you probably got the random select here, so that's why you probably chosen B. But if you just randomly select an interview, can you kind of look at this number? All right, so can you find exactly 50 and 50? All right, if I go to just randomly select, okay, like I said, I'm going to my group to randomly select 50 male and 50. So I want to choose 4 students to go to the conference, okay? And how do I choose 4 students? I want 2 male and 2 female. Okay, so I want the class to select, I want 4 people to go to the conference. And I want the 2 male and 2 female. So what do you think? How do I choose my 2 male and 2 female students? Well, if I just randomly select, don't do anything, just pure randomly select or simple random select, it's probably hard to find exactly 2 male and 2 female, okay? That's the similar situation in here. So in order to find the exact number of male and female, you must separate into group first, separate into male group and female group first, and then go to randomly select the number you want. So you can get an exact number. All right. If this one is said, I'm randomly select 50 male and female, of teacher, 50 male and female, randomly select 50 male and female. Now this will be purely random select. But this time it said select 50 male and 50 female. So I think this one imply you have to put in a group first before you randomly select. Okay, so anyone change the answer? Let's see. Okay, so we have a C, stratify. Yes, all right. Now got a lot of C here says stratify. That's exactly right. Okay, that's exactly stratify do in there. Okay. Number 10, to avoid working late, the quality control messenger inspect the last 10 items, of the day. So which method is that? Number 10. Okay, VB. Okay, all right. Yeah, that is B. That's exactly right. Okay, so because look at it, to avoid working late. So now why, it said the person said, yeah, I only work from 9 to 5, right? I'm not going to work anything past 5 or anything earlier than 9. All right, so, avoid working late. They only inspect the last 10 items produced that day. So that's just convenient. And apparently that is not a good method. Okay, convenient, but it's not a good sampling method in here. Okay, number 11, this is involved in chapter 2 already. So chapter 2, we have starting having the calculation. So we're gonna need to find the class width for the table, find the bin point, and then find the class boundary for the first class. Okay, so how do we do this type of question? This is the first class, right? This is the first class. Lower class limit is 50, upper class limit is 52, frequency is 5, okay? So first, what is the class width? Is class width gonna be 2 or 3? Okay, so now we have a kind of evenly split. We have some 2, we have more people got 3. All right, so the class width, look at it. If you choose 2, they have 2 right here, right? So sometimes you say multiple choice, is easy, but easy to confuse you as well. Okay, so you have to be very careful. Even if it's multiple choice, you have to check all 3 of them. This one you have ABC, so ABC all have to be exactly the same, the correct one to get a right one. Class width, you need to use the lower class limit minus the previous lower class limit. Okay, so you're gonna use the 53 minus 50, so the class width is 3, not 2. If you're using 2, you probably use the upper one minus the lower one. Okay, so you need to use the lower class limit minus the previous lower class limit, or you can use the 62 minus 59, or you can use the upper class limit, but you need to minus the upper class, the previous upper class. Okay, so if you use the 55 minus 52 is 3. Any one table can only have one class width. All right, so it doesn't matter you use the upper one or the lower one, but you have to minus the same one, the same upper, or, if you use the upper class limit, you need to minus the previous upper class limit. All right. If you use the lower class limit, you need to minus the lower class limit, and the answer will be the same, will be all 3. Okay. So that means C and D is incorrect. All right. Now, do we choose B or C, A or B? Apparently, the second one, the bin point for the first class, they are all 51. So apparently that should be all 51, right? So how do you do the how do you find a class? How do you find a class bin point for the first class? Okay, so you using the, that's why sometimes you get confused, right? So the bin point formula here is using the upper class plus the lower class. So 50 plus 52 and then divided by 2. Okay, 50 plus 52 and then divided by 2. So that is how you get a 51. All right. If I want to find a second class limit, a second class beam point, I don't have to do this again. I just using the first class beam point at a class with 3. So I know the second class beam point. So this beam point is 51. This second class beam point gonna be 54. And the next one will be 57, right? You can just add this one, and then this will be 60, 63. That kind of thing. You can just add a class width, because the difference of the beam point is also equal to the class width. All right. So we finish the B, class boundary for the first class. So which one is the correct answer? Do we have A or B is the correct answer? Piper, you answer. A or B? Okay, all right, good. B is the correct answer, okay? When you have a boundary on the lower class limit, you need to minus 0.5. On the upper class limit, you need to add 0.5, all right? So that is called a class boundary, all right? So if you haven't gone through that one, you should for the chapter 2. Okay, so B is the correct answer, right? A for C is incorrect. Okay, number 12, Ozai. So what is the Ozai graph? Ozai is used for the cumulative frequency or cumulative relative frequency graph. Okay, so that means this graph is keep adding up. You never go down. If you don't have anything in the next class, this will stay the same. Okay, since it's cumulative, so the Ozai graph will never going down. All right, and we want to use the Ozai to approximate the number in a sample. So since this is cumulative, that means the last number is the total. The last number is the total of the sample. So if you look at this one right here, this is approximately what? Like 80. All right. So the correct answer for this one should be D. Okay. So I just showing you how to read this graph. Any questions? All right, yeah, D is the correct answer. Okay, good. Okay, let's look at number 13. This one, you want to write some kind of phrase or some sentence to complete the statement for the answer, right? So this one is use the relative frequency histogram. So this is relative frequency histogram. So relative, that means it's kind of like a percentage or something like that, right? Okay, I'm just trying to see if anyone trying to get in that way. Okay, so the first one right here is identify the first class with the greatest and the class with the least relative frequency. Okay, so which class has the greatest relative frequency? Okay, we know the highest one should be the greatest one, right? So the greatest relative frequency here is 0.35. And what is the class in here? Well, this one is using the beam point. So the class from here, you can see from here to here is this is 100, this is 110. So that means this one should be 105, right? And then up to here, this should be 115. Okay. So the class with the greatest, okay, the class with the greatest relative frequency should be from 105 to 115. And then this has two answers, right? We also have to answer with the least relative frequency. So which one is the least one? When you look at the least one, you look at this one right here, okay? So that's the least in here. So this is probably around, I would say around 0.03 or 0.04, Okay, and this class here should be 155. So from here to here. All right, so this should be 145 to 155 that way. Okay, so that is the least relative frequency. And approximate the greatest relative frequency, or the greatest one here is 0.35, right? This is pretty obvious in here. The least relative frequency, how do I approximate in here? I know this one is a little bit more than a half, from here to here. Up here is 0.5, right? So this is less than a little bit more than a half. So our approximate, this is 0.03. If you approximate 0.04, it should be still okay that way because, it's approximate in here. Okay, but you don't want to approximate. This one is 0.02 for sure, because you can see this is more than a half. All right. Any questions? Okay, number C, approximate relative frequency of the fifth class. So you need to go to see which one is the fifth one. So you have a 1, 2, 3, 4, and 5. So this is the fifth one in here. Okay, so can you type what is the relative frequency for this one, number 5, the fifth one, according to your reading from the graph? Okay, all right, pretty accurate. Okay, 0.08, 0.09. I think they both should be good. Yeah, this one you can see is more than a half, right? More than between 0.05 to 0.1. This is kind of more than half in the middle in here. So our estimate 0.08, 0.09, both should be all good. Okay. But don't forget a 0 in the middle. It's not a 0.9, it's 0.09, okay? Yeah, so. Okay, number 14, let's see. What do we call this graph? Anyone? Oh, already telling you here, stem and leaf, right? I'm trying to test you the name for the stem and leaf, but it's already saying here. All right, what is the minimum and the maximum entrance? Which one is the correct answer? Okay, you have A, B, C, D. Which one is the correct answer? Let's look at the answer. Type your number. Okay, so someone type the number. What I'm saying number here, it's just type the choice A, B, C, or D will be easier next time. Okay. All right. So the first number, look at the key here. This is 11. 9, so that means 11.9. So the first number should read as 11.6, and that should be the minimum one. The minimum is 11.6, not 116, right? So it should be 11.6. And the last number should be the maximum. So that's 17.8, because you have to look at the key. It's not 178. It's not 178, right? It's 17.8. So the correct answer should be A. All right, correct answer should be A. Yeah, all right, okay, good. A lot of A's. Okay, number 15. Let's see. Can you explain the difference between the class limit and the class boundary? You can turn on your speaker. Let's see. Can anyone explain that? Turn on your own speaker. We have a volunteer.
Class boundaries are the numbers in between that set, and class limits are numbers that don't go out of that class.
Okay, all right, close enough. Okay, any other person, any other people want to repeat or say your own word? Okay, let's go back here to look at one of the class we have. Okay, all right, I dropped too much in here, but okay, I'm trying to just don't get right. All right, never mind. Okay, so let's look at the class limit in here, right? The class limit on the left side is called a lower class limit. On the right side is called an upper class limit. So apparently the class limit it determines which numbers can belong to this class. Okay, so that's the class limit. All right, if I'm a 53, it's belong second class in here. If I'm a 50, that's belong to the first class. So basically, this class limit separate classes, right? Separate the classes in here. And the class boundary actually is trying to connect the two classes together. Okay, so if we drop using the class boundary is kind of using for the histogram, right? The histogram we're using the class boundary for the for the graph. Okay, so look at this one right here. I drop using the class boundary. So if I drop the class boundary in here, this upper class, this class boundary will be 52.5, right? So now I have this one is 52.5. Okay, and then I connect to the next class, and this one is 5. Okay, this one is 5 in here. And then my next class is 53 to 55. So on the left side, we are minus 0.5. So this lower class limit boundary will be 52.5. And this 52.5 is the same as the upper class boundary for the first one. So when I try to drop A in here, I just connect this one. Okay, I just connect this one, and then this is A in here. All right, so you can see this class boundary, it connect the two classes together and forming the histogram without a gap. Okay, so that is the class boundary. So basically, the class boundary is trying to forming the histogram without a gap between them. All right, so that is the the key thing in here. Okay, these two. Number 6 here, this is called a dot plot. Okay, so we have this one is called a dot plot in here. The dot plot, you read the dot plot, basically you just put a dot on the, if you have one number, you put a dot on the top of the number, right? So apparently this one is a 67. So I have a 1, 2, 3, 367. So I put a 3 dot on the top of them. Okay, so can you convert this dot plot into stem and leaf? Okay, so can we convert that one into stem and leaf? And then let's see which one will be the correct answer. A, B, C, D, which one will be the correct answer? Okay, let's see, do we have an answer? This one you have to be very careful, right? So the most number is the what? What is the 60? 60 should be the minimum. Okay, 60 is the minimum. All right, and then this one is the max. This one is the largest number, so this one is the maximum. All right, so maximum should be 81. So if I look at this one, this is incorrect. This one is incorrect. This one is incorrect, right? So I only check the minimum. So the only thing correct here is I have a minimum 60, I have a minimum 60, I have a maximum 81. So the possible answer here is either C or D. Okay, either C or D in here. All right, we got a lot of D's, said D in here. Okay, D is the correct answer. Okay, so why D is the correct answer in here? If you look at D, we have I usually look at the most frequent one, right? So that's easier to check. So I have a 367. Okay, if you look at the C, I only have a 167. I only have a 167, and then I have a 368, which is not correct. Okay, and then this one, if you check this one right here, I have a 367. All right, so that is right. I have a 367, so that's why we don't have a 68 in here, right? So this one is incorrect. All right, so the only thing correct here is the D. Okay, but if you can just check the minimum and the maximum, you can eliminate A and B very quickly in here. All right, so that is how you convert the dot plot into the stem and leaf. Okay, any questions? All right, let's go to look at this one right here. We want to, this is a data set, right? This data set represents the alcohol related driving fatalities in thousands in US over a 20-year period. So we want to use a time series chart to display the data and then look at the trend in here. So same thing as this one, okay? We want to do the time series, or sometimes we say, you know, do a scatter plot data, right? So how do I do the time series data? This one, we can use the TI-80 using the calculator. Okay, so I'm gonna show you the calculator, which I opened it earlier. For this one. Okay, I'm trying to see the data. Okay, so we're gonna go to the calculator, go to step. All right, go to step, and anything, if you go to the calculator, anything with STAT, state is our favor. Okay, so we're gonna go to enter in here, and if you already have the data right there, you can just go to the very top of L2 and hit clear, enter. Everything will be gone, will be cleared out. So apparently I need to clear this data out. All right, so go to the very top, highlight it, and hit clear, enter. Everything will be gone. All right, so we're gonna input a year. We wanna input a year into L1 or X into L1, right? And then this is the outcome. We're gonna input into L2. Okay, so we have a 1983. Okay, so that up to 2001. Okay. All right, so and then on input L2 in here, I will cursor to the L2, right? So we have a 25. Okay, so when you input the data, just make sure you have the same number in L1, same number in L2. This is kind of like a pairing. You have to input in a pair. If one side is longer or shorter than the other, it will give you the error message and you won't be able to graph or calculate. Okay, so that is very important. Always make sure you have a same length in here. All right, so now we're gonna do the graphing. So if you look at this one right here, the blue one, it says state plot, okay? So this is graphing the statistic in here. And if you want to go to exit the blue one, you have to hit second. If you want to exit the green one, you have to hit alpha first, okay? So if I hit second more, will be quit, right? That one, so I back to the main screen. And if I hit y equal to, this will be y equal to. All right, I don't need a y equal to for now. So I'm gonna go to the state plot. So hit second y equal to. So you will get to the state plot in here, hit enter. The state plot default usually is off, so you need to turn it on. So you hit enter. Okay, make sure that one is on. All right, so the on is a highlight. The first one is called scatter plot. Okay, if later on we say we want to do the scatter plot, and then the time series, these two are very similar, right? Actually, the second one. All right, so the second one is a time series. Time series is just connect all the dots together. So let me show you the scatter plot first. All right, and then default. L1 going to X, L2 going to Y. If you happen this input into L3 or something, like I said, you input this into L3, you don't have to re-input the data. You just hit second 3, and then this will change it into L3. Okay, so change this one is much easier than re-input the data. All right, so second 2 will be L2. Same thing as this one, right? If this one you input into second 5 will be L5. All right, but default is always L1 and L2. So if you input in a default, you don't have to change anything. Okay, and then we're gonna just hit graph in here. When you hit graph, if you don't see anything, that means you have to go to zoom. And zoom number 9, zoom state is our favor. So you can scroll all the way down to here, or you can just type 9, zoom number 9. Now you can see this is the scatter plot. Okay, I like the scatter plot because I can see that each data, this is called a first-hand data or the raw data really clearly. Okay, you can see this one is going down, so this is negative trend, right? So when X increases, Y actually is going down. Okay, and then if you want the time series here, I just change this into the 9. Okay, and now we're giving you the time series. Right. So that is how the graph look like in the time series. All right, so what is this trend in here? This appears the number of the alcohol-related fatalities is decreasing, right? It's decreasing in here over the years. Okay, so I think we probably got a little bit more awareness, so that's a good thing, right? So the alcohol-related extent actually is decreasing in here. Okay, so that is how you can use the time series, to describe this kind of situation. The other two is similar, right? This one is pretty similar in here. Okay, so that is how you use the calculator to do the graphing in here. All right, any questions?
Okay, so after I did the stat, right? I put in the L1, L2, and then when I did second stat plot and, I switched it to red, I did the scatter plot and I pressed enter, I didn't get anything that did that for the graph. Did I miss a step?
Yeah, you have to go to zoom. Just like
Zoom.
you did all the thing. Zoom number 9, zoom state, hit enter.
Zoom 9. Oh, okay,
Yeah.
I got it. Thank you.
Yeah, that's the magic zoom. Yeah, so yeah, if you follow that one, yeah, just using the zoom, and then it will automatically let zoom. This one, I don't recommend you to using a zoom in or zoom out. Just go to zoom number 9, zoom state. That's a quick and easy one.
Okay, thank you, thank you.
Yeah. All right, so that is how you do this one in here. You can plug it into the different data and then graph them. Okay. Okay, number 19. How do you find the mean, median, mode? Sometimes we also call it triple M, right? 3 M's, triple M's. Okay, so how many data do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, if you do this one by hand, you're gonna have to put it in order first, right? And if you have to do it by hand, I usually put it in the Excel. Okay, so you put it in the Excel and then sort the order, and then you choose since this is an even number, so you have to pick the middle two. number and then add them together, divided by 2. That would be the median, right? And the mean here is you just add all of them together, divided by 10. All right. Do we have a more here? Anyone?
65?
Yeah, okay, we do have a more because you have a 3 what? 65, that's the most one. Okay, the more is the most frequent one. All right, so that is the more. And I can also show you how to find the mean and median in the calculator, which is if you do the mean, and the median in the calculator, you don't have to short. All right, so let's do this one more time. I'm going to my step, edit, and this time I'm gonna clear everything out. Okay, I don't need any more. All right, so clear it up. So you go to highlight the L1, hit clear, enter, everything will be gone. Okay, and the default, usually if you only have just one set of the data, I use use L1. So 65. Okay, so make sure I have a 10 data. So I'm in number 11. So that means I have a 10 data in here, right? Okay, so sometimes using calculator for this one a little bit kind of cheating because the calculator did everything for you. All right, so you go to stat cal because you want a calculator to do the calculation. So this time, after you add the input of data, you want to switch to the middle one for the calculation. You're gonna using the one variable state. Okay, everything we talk in this course is only just one variable. We don't use the 2 variable state, things like that. All right, we hit enter. Default is L1. Okay, and my frequency, I don't have a frequency in the L2. If you have a weighted bin, you can put a frequency into L2. But default for the frequency will be everything just 1, okay, which is the one we have in here. And we're gonna go ahead, hit calculate. All right, so that is your mean. 63 is your mean. And then if you scroll it down, this calculator giving you the n is 10, minimum is 58. Fourth quadrant 60, median 64. So that is your median in here. Okay. So if you do this one right here, telling you 2 answers already, telling you the mean here is 63, so you don't have to type the addition. And then it also telling you the median here. MED is the median. Here is 64. Okay. And giving you the Q1 and Q3 as well. So if you want to find the interquartile range, you're using Q3 minus Q1, right? So it's all in here. Okay, and then giving you the maximum. So if you want a 5-number system, these 5 number all in here. Minimum, maximum, Q1, Q2, Q3 all in here. All right, so that's one step giving you everything pretty much. Any questions about this one? All right, so this one, you want to find a median, whatever this is talking about, I usually look at the question first, right? Whatever that described right here, you want to find a median. Okay, so I have a 2, 4, 6, 8, 10, 12, 14 data, okay? If you don't want to shop, you can just do the same thing, put in the calculator, all right? Put in the calculator and then, all right, so you go to stat, edit, put a calculator, all right? I'm not going to input this one again, but I'm just showing you the step again. So you go to step edit, input into L1, and then go back to state again, and then using the cal, using the one variable calculation, and then your default is L1, right? If you, for some reason, you didn't input into L1, you can just have a second through. This will change it into L3, right? So whatever the column you input, the list you input, it will be right there. And then just go ahead, hit calculate. Oh, I don't have anything in L3. All right, so just go ahead and hit calculate, and then scroll it down. Scroll it down, you will see the median right here. Okay, so that should be really quick and easy for that one. Okay, 21. This is using the bell curve. All right, bell curve distribution using the empirical rule for the bell curve. So what is the empirical rule for the bell curve? Well, if you go to open the formula sheet, we're giving you the three numbers, right? Between the, let's see, let me go ahead. Let me see if I can open my order so I can draw for the bell curve. Okay, so if you draw a bell curve in here, okay, and then your mean is in the middle. All right, like I said, this mu is 10, and I'm gonna just get my sigma is 1. Okay, so if you draw for the mean in the middle here, if you have an A and subtract 1 standard deviation, that will giving you the middle one will be 68%. Okay, so what's the middle one? This is plus, so you have a 10 plus 1, this will be 11, so this will be 11. 10 minus 1 will giving you 9, so this side will be 9. Okay, so between 9 to 11, they will giving you 68%. And then between 8 to 12. Okay, so I'm using this number easy to calculate. Okay, so what is 8 to 12? Apparently 11 plus 1 again giving you 12, right? 9 minus 1 again giving you 8. So this one from 8 to 12 is 95%. Okay, so 95% is in a plus minus 2 standard deviation. 68% here is mu plus minus 1 standard deviation. Okay, and then we also have a third number here is called 3 standard deviation. All right, so what is the 3 standard deviation in here? All right, so in order to get through it, I need to 12. 12 will need to plus 1 again, so this will be 13, right? Let's drop this a little bit longer. Okay, and then the A minus 1 again will get 7. So between 7 to 13 is mu plus and minus 3 standard deviation. So plus minus 3 standard deviation, we are giving you 99.7%. 99.7. So from here to here, you have a 99.7%. The entire bell curve is 100% or just equal to 1 if you're not using the decimal point. Okay, entire bell curve is 100% in here. Okay, and that is called the empirical rule. All right, so now let's go back to look at what we have in here. Where's in the chat? All right, so let's see what we got in this equation. This one is said the mean test score is 70. Standard deviation is 6. Okay, we want to find a percentage between 64 to 76. All right, so remember now we can drop a new one, okay, but we're still using this similar one to do this calculation. So if I drop a new bell curve with my new mu and sigma, my mu here is 70, my sigma here is 6, right? And then we want to look at between 64 to 76. So how many percent is that? Anyone? Compare this one to what we have earlier. Okay, let's see. Type your answer, trying to see if you can get an answer. Okay, so we have a 64, 66. Okay, the answer here should be 68. Okay, should be 68%. Because when you have a mu plus minus 1 standard deviation is 68%. Mu plus minus 2 standard deviation is 95%. Those are three numbers you will need to know. I think it might be in a formula sheet. Okay, if you print out those formula sheet, it might be in a formula sheet. All right, so between 64 to 76 is to the left is minus 1 standard deviation, to the right is plus 1 standard deviation. So that is 68%. Okay. If I only ask how many percent between 70 to 76, and that would be half of the 68 because bell curve is symmetric. Okay. So this will be just half of the 68 because from left to the middle to the right, total is 68%. Okay, that's plus minus 1 standard deviation. That's 68%. So that means if I only have a middle, I only have this from middle to the left, or even from left to the middle, it's the same thing. So this is 34%. This is also 34%, right? So you don't really have to remember that many numbers. You just need to know 68, 95, and 99.7%, and you can figure it out that way. Okay, so the correct answer should be D in here. Okay. Number 22. Let's see if you can figure out this one on your own, since we still got a little bit time. Okay, I'll give you a few minutes, a couple minutes. Let's see. SAT mean is 462. Standard deviation is 98. Same thing, use the empirical rule. So what percentage will between 462 to 560? So drop a little bit bell curve, and then you can drop a little bit bell curve, right? Okay, so my middle here is 462. Okay, and this one, so it lie between 462 to 560. All right, so if I add a 98 in here, if I add a 98 to the middle, that will give you 560, right? So that is 1 standard deviation away. Okay, only 1 standard deviation. So that is only plus 1 standard deviation. Do not have a minus 1 standard deviation. So how many percent is that? That should be 34%. Yeah, B is the correct answer. That's right, we got all B's. Yeah, that is the correct answer. Okay, good. All right, let's move on to 23. We need to know how to calculate your own GPA, right? Same thing I usually tell people, say in this class, you should be able to find your own final grade. Okay, you should be able to calculate your own final grade in here according to the syllabus, because we're gonna have a test how to calculate your own grade or your own GPA in here, right? So encourage grading scale, A is 4 points, B is 3 points, C is 2 points, and so on, right? And this is according to the credit hours. So if a student earn an A in 4 credit hours, D in 2 credit hours, and so on, so what is the student's GPA? All right, so that is called a weighted mean, right? So the weighted bin here, X bar is equal to the sum of all X value. You need to times the weight and then divided by the sum of the weight here. Okay, so how do you do this one right here? Well, you have a A. Okay, let's see. You have a A, which is 4 point, right? A is in the 4 credit hours, so that's 4 times 4, and then we have a weight here is 4. Okay, so that's 4 times 4. Okay, and then you have a D, which is D is only 1 point. Okay, so that's 1 times 2. All right, and then we need to plus 2. That's 2 credit hour. Okay, and then you have a B in 3 credit hours. So B is 3 point. So that's 3 times 3. Okay, and then we need to add a 3 in the weight. All right, last one here. You have a C in a 3 credit hours. So C is only 2 points. So C in a 3 credit hours, so 3. So we need to add 3 for the 3 credit hour, right? And then you just add them together. So that's 6 plus 6. So that's 12 credit hours. 4 times 4 is 16 plus 2 plus 9 and then plus 6. Okay. All right. So let's see what do we got in here. That's 18, 24, 33. Okay. 33 divided by 12. Or you can divide it by 3. So that's 11 divided by 4. 11 divided by 4 giving you what? Not 3, 2. Okay. 3. So that's giving you 2.75. All right. So that GPA here is what? 2.75. Okay. So that's how you calculate the GPA. All right. You can also put this one in a calculator if you want to. You put an A, B, C, D grade into L1 and you put a credit hour into L2. All right. And now we're giving you, if you using L1 and then L2 in here, that will giving you the weighted bin. Okay. So you can do it by hand as I just did it by hand, or you can put it in a calculator as well. And I will show you how to use a calculator in this one. And for this table, if you want to calculate the sample bin in this table, we need to find a bin point first. Okay, so find a bin point before you can input it into the calculator. Okay, if you don't want to use the calculator, you're gonna have to do the similar in here. Okay, similar in here. Number of the customer is the weight, or sometimes we call it frequency. Okay. So you're gonna using X times F and then add that together and then divided by the sum of the frequency of this one. So before you do this one, you have to find a bin point first. Okay, let's see what is the first class bin point.
$1.5 for the first one.
Okay, all right, good. So that is 1.5. And what is the, if you forgot how to find a bin point, let me just show you the table, the formula sheet, which you can use it for the test, right? So this is your formula sheet in here. It usually telling you how to find a bin point. Okay, so this is how you find a bin point using the lower class limit plus the upper class limit divided by 2. Okay, so that's how you find a bin point in here, and that is how you find a weighted bin. Okay, the weighted bin in a frequency distribution, the range, the population variance, standard deviation is all in here, and then you have an empirical rule. Okay, one thing we do skip is the stable theta theorem. We skip this small part because this is not symmetric. So these three numbers are in a formula sheet, so you kind of know how to use that one, as we pointed out earlier. All right. So we have a we have a 1.5, and where's the class width for this table? Class width
4.
4. Okay, so that means I will just need to use this one to add a 4. Okay, so that will be 5.5, and then this will be 9.5. All right. Okay, and then this is 13.5. Okay, and then 17.5. And then this will be 21.5. Okay, and then last one will be 25.5. Okay, so you can see, just only need to find out the first class being point, and then you just add a class width. So that should be easy in here. And then instead of using this one, because this number getting a little bit big, okay, so I'm gonna put in a calculator. You can do it by hand. If you do it by hand, you need to use 1.5 times 12, and then plus 5.5 times 14, plus 9.5 times 13, all the way down, and then divide by the sum of this whole thing. Okay, so that will give you the sigma of f in here. All right, but I'm gonna put in a calculator. So so I go to stat, edit. Okay, I'm gonna clear everything out. So I'm gonna using the D4, L1 and L2. All right. So my L1 will be my beam point here. Oh, hold on. I wasn't input into the right one. All right. Okay. So okay, and then we're gonna input a frequency into L2. Just make sure your frequency match that well. Okay, all right. So after we input a frequency in here, we go to stat and then do the cal. And then same thing, we just do the one variable statistic. But this time you do have to type it into your frequency here into L2. All right, so second 2 is L2. And then we just hit calculate. And that is our weighted bin. Okay, and that's the weighted standard deviation as well if you need a standard deviation. If I need a median for the entire table, I also have this one right here. Look at it. So it's very convenient. This is one step giving you all the numbers you want. So if I round to 1 decimal point, this will need to be round up, right? So it will be 9.1. Okay. The second digit is 5 or above. You need to round up. So that's round to 1 decimal point will be 9.1. All right. Okay, so we do have a 9.1 right here. You can see this one is so close, right? So if you're not careful, you will get to the wrong answer in here. Okay, any question about this one? Okay, number 25, you want to find a standard deviation. So, you can put it in a calculator, find a standard deviation as well. Okay, if you don't have a weighted one, you just input into L1. But let's see, which one do you read? If I have assume my data is using this one right here. So I'm gonna using this data. Oh, we can just go ahead and do one of these. Yeah, I'm gonna go to state. And I really like that table, so I'm gonna leave that table alone. I'm gonna input my data into L3. Okay, so let's just input this one into L3. Okay, so I have 9 data in here, right? So let's see, do we have a 9 data? Yeah, we have a 9 data in here. Okay, so I'm going to step and then go to cal using one variable state. Okay. This time I have my data into L3, so I'm gonna have to hit L3, right? My data frequency default will be just once, it's just a list. So I have to clear out the L2. Now I hit enter. Okay. So I got a bin here as 25.2. Okay, it didn't ask the bin, but what it asks here is ask for the sample standard deviation. Okay, so we have a 2 standard deviation in here. We have the first one, x of x will be 17.8, and we have a sigma of x is 16.8 if we round this one up. So we have a 16.8 and 17.8. So which one is the correct answer, anyone? Which one do we use? Or which one do we read? Okay, so calculator do all the calculation for you, but you also need to choose the right one. Since this one, it says sample standard deviation. So that means this data is using sample. So using sample, you will need to using x of x. Okay, x of x is for the sample standard deviation. If you look at the calculator, this sigma x is for the population standard deviation. All right, this is for the population. This one, it says sample right here. Okay, so since it says sample, you need to use the sample standard deviation. So sometimes you have to read it carefully. So the answer will be 17.8, not 16.1. Okay. Any questions? Okay, a little bit more practice empirical rule again. Let's see if we can get this one right on your own. We have a little bit more empirical rule. Apparently, empirical rule is so important in this chapter. Okay, so 26, let's see what is your answer. Okay, anyone got a 26 answer?
C.
C? Okay, C is 95%. Okay, all right, so that's good. Look at that. If you have a 100, in order to get 130, you have to add a 1 standard deviation, that's 115, and then add another 15, give you 130. So that's 2 standard deviation away, right? And then on the left side, if you minus 15, you got 85, and then you have to minus another 15 to get 70. So yes, that's exactly 2 standard deviation away. So, both from the 2 to the left, 2 to the right. So yeah, exactly 95. So that's good. All right, 27, very similar. This is between 53 to 77.
D.
Okay, 27. Okay, D is 99.7, right? So let's see from 65 to get to 77, you add 1 standard deviation will be 69. 2 standard deviation will be 73. 3 standard deviation will be 77. Okay, so that's 3 standard deviation to the right. And 53, you minus 1 will be 61. Minus 2 standard deviation will be 57. All right, and then minus another standard deviation, we're giving you 53. So that's exactly 3 standard deviation to the left and 3 to the right. So that is exactly right, 99.7%. All right, looks like we're doing very well. Okay, 28. Okay, so this one probably a little bit different than not as straight as the other two, right? So if you look at 490, okay, plus 490 plus 96, how much is that? 586.
192.
586, right?
2 deviations.
Okay, so that's 1 standard deviation away from here to here. That is 1 standard deviation away. Okay, if you use 490 minus 96, will be giving you somewhere right here. 2. Okay, all right. My brain hurt. Let's see how much is that using a calculator. All right. Okay, let's see. 490 minus 96. That's 394, right? And then we have to minus 96 again to get 289. Okay, so this one to the right is 1 standard deviation away, but to the left is what? 2 standard deviation away. Yeah. Okay. All right. So we're gonna have to calculate into 2 parts. Okay. Calculate into 2 parts in here. From middle to the right will be 34%. Yeah, because half of the 68, right? 34%. From middle to the left is half of the 95%. Half of the 95%. Okay, so that's 47.5%. So 47.5, so you have a 47.5 plus 34. Okay, so that will giving you what? 81.5. Is that right?
Okay.
Yeah, so that is how we calculate this one. So this one, we don't have exactly 2 or 3 to the left, to the right. So we have a 1 to the right, 2 to the left. So that's why we have to calculate separately and then add them together. Questions? All right, we have a little bit more sample bin again, find a sample bin, which is weighted bin. So this is kind of repeat, right? Step 1, so let's just go through the step again. We are not going to put in a calculator for this one. But what is the step to do this one, everyone?
Midpoint.
Bin point, that's exactly right, okay? You need to find a class bin point. How much is a class bin point here?
34.5.
Okay, good, 34.5. And what is the class width?
10.
Yeah, class width is 10. So we just add a 10 for each one of them. Look at it. So we don't have to calculate everyone. Okay, so we just add a 10, we just add a 10, All right, you just add a 10 for each one in here, okay? And then you put into the mean point into L1, put the frequency into L2. And you will be able to go to using the one variable calculation, you will be able to get a sample mean in no time that way, okay? So that's how you do this type of question. All right, number 30, how do you drop a box and whisker plot to represent the data? Okay, so the box and whisker plot is using the 5 data point. So what is a 5 data point? 5 data point is minimum, maximum, okay? And then you have a Q1, Q2, and Q3. Q2 is the median. All right. So if you do this one by hand, it will be a little bit challenging because you have to sort the data first, okay? And then you have to find a median first and then separate into 2 parts. Find a median for the first half will be Q1. Find a median for your second half will be the Q3, okay? All right, and then you have a minimum in here and then drop the minimum to the fourth quadrant. So this is the minimum, all right? And then this will be the Q1, okay? And then you drop a box in the middle. This is Q3. Your Q2 may or may not exactly in the middle, depends on your data, okay? All right, so let's say, assume my Q2 is right here. And then you extend it to the maximum. Okay, so that is your box and whisker plot in here. All right, but you have to go to calculate these 5 numbers in here. Okay, so I can use the calculator. Can we use the TI-84 calculator on the phone? Okay, all right. The answer is yes. You can use that one. You just cannot go to the phone other things. I know a lot of people want to use the app because the app it is cheaper than the handset calculator. If you use the TI-83 or 84, use the TI-84 app, it probably I would suggest go to download the one without a commercial. It only costs like $4.95. Because some students trying to using a free app got a lot of commercial. Okay, so you might trigger the things that say you use other page or something, and plus the commercial you have to click on there in order to continue. So it's very annoying. So I would just say skip one Starbucks coffee one time, you can have the app for $4.95, right? And as long as you own the cell phone, the app will stay there forever. So it's worth it without a commercial app. Okay. All right. So I'm going to re-input this whole thing in here. Okay. I'm gonna delete everything. I don't need this. Okay, so I'm going to input this data into calculator because by the time I input that, I short that, I might input that here already, right? So let's just go ahead. Okay, all right. So I have a 30 data in here, okay? And how do I draw for a scatter plot? Actually, before I do that by hand, I have to go to the cal, and then yeah, this one I input into L1. Okay, so I'm going to do the calculation in here. So I have a minimum is 31, Q1 is 56, Q2 is 72, Q3 is 83, and I have maximum is 99. All right, so that is the 5 number I can graph by hand. But one thing is the calculator also can do the scatter plot for you. Not only scatter plot, do the box and whisker plot for you as well. Okay, so I'm going here. I just choose this one right here. This is scatter plot. Actually, this one is also a scatter plot. Okay. I'm sorry, not a scatter. Box and whisker plot. Okay, sorry about it. Correct it. Both are the box and whisker plot. All right, scatter plot is the first one. Okay. So these both are box and whisker plot. This one with a dot 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 at the end. This one can graph the outlier. So I usually like to choose this one better because I can find the outlier that way. All right. And then I'm gonna just go ahead and hit graph. Okay, same thing. If you don't see anything, go to your magic zoom. Okay, zoom number 9. All right, so that is my box and whisker plot. And this don't have anything like a broken point right here. So that means my data set do not have an outlier. Okay, this data set doesn't have any outlier. All right, so that is how you do this one on the calculator. Okay, so I have this one, do this one in a calculator. You can do that by hand in here, but you just mark this one is 31, right? And then this one is 56. And then your Q2 is 72. Q3 is 80. Q3 is 83. Okay, and your maximum here is 99. All right, if you do that by hand, you just mark this one in here. Okay, so that's it. That's how you do this one in here. All right, let's move on to last a few questions. We have 36 questions. Wow, with this one, this review is a long review, right? Giving you double or triple doses in some of the question because the test question is only 25. Okay. All right, this one you want to find a Z-score. Okay, so how do you find a Z-score? Z-score is using X minus mu over sigma. Okay, so that is a Z-score, only 3 numbers, right? So you need to find the data value minus the mean divided by the standard deviation. Okay, so this mean here, the mean and the standard deviation is 81 and 3 respectively. The score here is 77. Okay, so this look pretty long, but you only need these 3 numbers. And then you just calculate this one. So apparently this will be -4, right? -4 divided by 3, so it should be negative 1.33. So what does negative Z-score mean? That means below the average. Okay, negative Z-score means below average in here. All right, any questions about Z-score? And again, this should be in the formula C, right? The Z-score, look at it, the standard Z-score, it is in a formula C in here. Okay, so you have a Z-score formula C. Okay, so this one you want to find the mean quartile. Okay, so what is the mean quartile? Let's see.
Second quadrant, Q2?
No, not a Q2. Q2 is called the median. Okay, let's see if we have a
12.5.
formula in here. Surprise, we don't have this one in here. We don't have that formula. Usually we do. Okay, so we usually, another thing we use here is IQR. We actually use IQR much often than this called mean quartile. Okay, IQR is using interquartile range is using Q3 minus what? Q1, okay? Because we usually using the interquartile range trying to identify the outlier, that kind of thing. All right, so the interquartile range, mean quartile. Then the mean quartile is using Q1 plus Q3 over 2, I think. Let me just look at the mean quartile. Not a quartile, but the mean quartile. Mean quartile is a numerical value meanwhile between the fourth and the third quartile. Okay, so it's 1/2 of the sum of the fourth quartile plus the third quartile. Okay, all right. Okay, we actually do not. I don't know why that one topic in here, because we usually using the interquartile IQR interquartile range more often than that one. So this one we don't really mean quartile. Okay, so now you know using the Q1 plus the Q3 and then what the sum of the fourth and the third quartile. Okay, so mean quartile here, instead of using the IRG, this is using Q1 plus what Q3 divided by 2. All right, so that's the mean quartile. Okay. All right, I thought it should be in a formula sheet, but it's not. You can add this one on the formula sheet if you want. Okay, I'll let you add this one, because we don't really use this one that often. So not trying to require everyone to remember that. So mean quartile is using Q1 plus Q3 over 2. You can add it to the formula sheet. Okay, mean quartile. All right, so basically you can just input this one in a calculator, and a calculator will find you the Q1 and what. If you go to the stat cal, right, and then the one variable calculation, you scroll it down, you have a Q1 and Q3, and then you just add a Q1 and Q3 together divided by 2. Okay, so I think this answer should be D in here, but you can go ahead, calculate on your own. Okay, 33, the test score. Okay, we have a few more. We almost, run out of time. So let's finish the last. By the way, this review, you have an answer key at the end of each one. So you will have an answer in here at the end of that. So you can check it on your own for the answer, okay? All right, so 33 test score for the history class and the physics class. Okay, you have a mean and a standard deviation. You want to see which one you do better. So what do you need to do? In order to know which one you do better, we said you cannot compare apple to orange, right? So in order for them to be able to compare, you have to compare apple to apple. So that means we're gonna need to change both of them into Z-score, okay? You change the history and the physics, if the history is the first one, the physics is the second one. So you're gonna have to change the Z-score, both into Z-score, right? History, so suppose the student gets 65 on history, so that's a 65 minus the mean of the history, which is 79. And then the standard deviation here is 4.5, okay? And then the physics Z-score, okay, 74 on physics, okay? And the physics mean here is 69, okay? Standard deviation here is 3.7. All right, so can you tell which one did better? Apparently, this one is greater than 0. This one is what? Less than 0, right? So apparently, this is a higher Z-score. I don't even need to do the calculation. I can see this one is above the mean. This one is below the mean. So the student performed better on what? On physics in here. Okay, you can go to do the detailed number, but you don't have to, because we know one is positive, one is negative in here. Okay, If both are negative, if both are positive, now you know how to compare the positive, right? The higher the better. But if you both are negative, if you have a -1 and -2, which one you do better? For example, if you have one is -1, one is -2, which one is better? If we both are negative, -1 is better than -2. Okay, -1 is greater than -2. All right. If you both are positive, you know 1 and 2, right? So 2 is better, okay, because 2 is greater than 1. But if you have a negative, both are below average, -1 and -2. A little bit below, -1 is better than 4 below, okay? So those, you need to be able to make a conclusion. Okay, number 35 is finding the G-score. 36 is also finding the G-score and perform which one better. So G-score is another calculation we need to have, right? So this is two bell curve and a G-score looks like an weighted mean. These three are the major calculation. Let's look at the last one, 34. Okay, how do you do the 34? 20-point quiz on the 10 student list before, what percentiles of the score 12 mean? So before you go to do this one, you have to line up because the percentile require you to line up. Okay, so if you line up here, this will be 8. Actually, you have a 7, 7, 8, 9, 10, right? 9, 10. And then next one is 12. 14, 15, 16, 19, and 20. Is that right? Yeah. Okay, all right. So we want to see what percentiles number 12 stand on. So first, how many data we have? We got 10. 1, 2, 3. We got 10 data because telling you 10 students. Okay. Okay, percentiles is trying to see how many below you. Okay, if you are in a 50 percentile, that means you are exactly in the middle. Okay, so this one is you have 1, 2, 3, 4, 4 to the left. Okay, and then 6 to the right. Okay, you have 4 to the left, 6 to the right in here. So the total is 10, so that is 40 percentile. So how many below you? 4 below you, 4 divided by the total. So it's 40 percentile. That's how you count it. All right, that's it for tonight. Any questions? Can you pull out the formula C on the phone as well? The answer will be no. That'll be too much. You can only have one screen for the cell phone. You cannot back and forth on the cell phone. Okay, so that's one thing. Yeah, for the formula C, we require you to pull it out because otherwise it will look like you go to the different formula, the screen. Any other questions? Okay, so the test is on the lockdown browser. We need to use the lockdown browser for the test. Okay, so you go to the quiz here. If you go to the quiz, all right, go to the quiz in here, and you will see the test. Okay, this test requires the lockdown browser. If you do not know how to do the lockdown browser, let me create. I think I might giving you a sample opening to check your lockdown browser. Okay, I'll create tomorrow morning. Giving you a sample lockdown browser in here. All right, so that way you can test. Okay, any other questions before we go? Can you use Excel? Yes, you can use Excel if you like Excel. Okay, one thing in Excel, if you find a way to be in Excel, is very helpful as well. But other than that, I think a calculator will do more things for you that way. Okay. All right, let me go ahead and stop the recording.